Assalamu alaikum, welcome to my YouTube channel. So today's topic about orthogonal set. What is orthogonal set in ordinary differential equations? Here's the definition. An infinite set of orthogonal functions is defined as follows: a set of real valued functions phi0 of x, phi1 of x, phi2 of x up to so on is said to be orthogonal on an interval a comma b if phi m comma phi n is equal to definite integral from a to b phi m of x multiplied by phi n of x ds is equal to 0. Then m is not equal to, and here's the m is not equal to, and this is called the orthogonal set. The norm length u of vector u can be expressed in terms of the inner product. The expression u comma u is equal to u square is called the square norm. Here is the square norm, and so the norm is equal to radical u comma u. Similarly, the square norm of a function phi n is phi n of x norm square is equal to phi n comma phi n, and so the norm or its generalized length is norm phi n of x is equal to radical phi n comma phi n. Here the phi n of x norm square is equal to ab definite integral from a to b phi square n of x dx. This implies that phi n of x norm is equal to norm phi n of x is equal to radical a to b phi square n of x dx. If phi n of x is an orthogonal set of functions on the interval a comma b with the property that norm phi n of x is equal to 1 for n is equal to 1 2 3 up to so on is the n, then phi n of x is said to be an orthogonal set on the interval, any interval. Here's the norms. What are the norms? Any orthogonal set of non-zero functions, any orthogonal set of non-zero functions phi n of x comma n is equal to 0 comma 1 comma 2 up to so on can be normalized, that is made into an orthogonal set by dividing each function by its norm, such as here 1 over radical 2 pi comma cos x over radical pi comma cos 2x over radical pi comma up to so on set is orthogonal set on the interval negative pi comma pi. Okay. Find the norm of each of the function. Here's the example. Find the norm of each of the function in the orthogonal set 1 comma cos x comma cos 2x up to so on set. Solution for phi naught is equal to 1. Here is 1. We have phi naught of x norm square is equal to negative pi to pi dx is equal to 2 pi. So norm phi naught of x is equal to radical 2 pi for phi now n of x is equal to cos nx comma n greater than 0. It follows that norm phi n of x norm square is equal to negative pi to pi definite integral cos square n dx is equal to, as we define negative integral definite integral is equal to 1 over 2 negative pi to pi definite integral 1 plus cos 2 nx dx is equal to pi. So this for n greater than 0 and norm phi of x is equal to radical. There's the end, and today's topic is very important for mathematics and engineering students. I hope you understand very well. Thank you for watching my video. Please subscribe my YouTube channel. Thanks a lot again. Okay, Allah Hafiz.